அருள்மொழி?
Yes, sir.
ஸ்டார்ட் பண்ணுங்கம்மா.
Good afternoon to one and all attending the session. I am Arulmoni, member of IEEE Photonics Society from the Department of Electronic and Communication Engineering, St. Joseph's Institute of Technology. I am here to volunteer for today's session. On behalf of ECE Department, St. Joseph Institute of Technology, St. Joseph Group of Institution, I extend my hearty welcome to Mr. S. Kamlesh sir. I did like to mention our beloved chairman, Dr. B. Babu Manoharan sir, and our managing director, Mrs. B. Jessipriya ma'am, and director, Mr. B. Sasishekar sir, and our principal, Dr. P. Ravichandran sir, for giving this wonderful opportunity to conduct this webinar. And special mention to our department heads, Dr. C. Jnana Kausalya ma'am, Professor and Head of Staff and Student Affairs, and Dr. G. Rohini ma'am, Professor and Head of Lab Affairs, for their guidance and constant support. Before we start the session, I would like to tell a few instructions to follow, followed by the participants. Kindly post your queries and questions in the chat box, and they will be discussed with the speaker at the end of the session. The attendance link will be posted at the end of today's webinar. Now I invite our speaker of the day to kindly start the session.
Yeah, thank you. And welcome to day 4 session in neural network. And thank you for the introduction. And first of all, good evening to one and all who are all participants in this wonderful workshop on day 4 neural network using Keras and TensorFlow. So today we are going to see about how we can classify the text. Okay, so till now we seen about like using some categorical value and then some numerical values, and then we trained the machine learning algorithm and deep learning algorithm, and then we get accuracy scores and all. But now in this session I am going to use same neural network algorithm only, but I am going to use text type of data. Okay, using Keras and TensorFlow, I am going to develop one neural network architecture. So that is generally the algorithm name RNN, recurrent neural network algorithm. So based on that, I'm going to train the text type of data, and we are going to check how it's working. Okay. So before entering into that part, we need to know how we can classify that text data. Okay. Why? Because here our data set in the form of only text type. Okay, so for example, you can take a comment in Facebook, or even comment in our chat box also. Okay, so we will have some text data. So if we need to pre-process those data, and you need to find whether it's a good review or bad review, like that. If we need to find, means we need to classify with some packages. Okay, so now I'm going to tell you what are the packages available in generally for text classification. Okay, and using NLTK. Okay, using natural language toolkit package, I'm going to show you some basic things how we can do those works by using text data. And after that, I'm going to show you the how we can build the recurrent neural network algorithm. Okay, so the two part of this session, the first part is how we can do the classifications. Okay, using some basic tokenizing and stemming, like that. We will be have some basics. Okay, some, if you have a text data, you have to do those things. Okay, so I will show you some basics, and after that, how we can convert our text data into an machine understandable data. Okay, so for that, what are the library packages are available, we are going to see. This is the first part of the session, and the next part, using recurrent neural network algorithm, that is deep learning algorithm, RNN. We are going to train the text type of data, and we are going to see how the output is giving an accuracy scores. Okay, so totally two part. The first, we will enter into the introduction of text data. Okay, so if in machine learning or deep learning, generally if you want to do some process with text type of data, means we have some library packages. Okay, one of the most important packages, like commonly used packages. One is SPACY and then another one is NLTK. Okay, so these two packages are mostly used for text pre-processing. Like if you take a generally text pre-processing or general steps means you will be have some basic steps, like for example tokenizing. Okay, so tokenizing is nothing but if you have a set of paragraph, okay, you can convert those paragraph into and words means you need to do tokenizing. Suppose if you have a sorry, if you have a set of paragraph, you need to convert the paragraph into a line, you can use tokenizing. Suppose if you have a line, okay, like one or two or three line, you need to convert those data into an words means you can use tokenizing. Okay, so I will show you how we can do tokenizing just for converting your sentence and paragraph into an words. Okay, so that is the use of tokenizing. Sentence and paragraph into an words. So that is the use of tokenizing. Then we are having some few steps in text pre-processing, like we need to do stop words. Stop words is nothing but some words will be a common, right? Like is, there, are, have not, like that will be have some words, right? So if you take a even paragraph or any sentence, you will be have some common words. Okay, so those words are called as a stop words. So you can remove those stop words. Okay, suppose if you need to remove means you can remove the stop words. So generally stop words you can remove it, and we will be have some other package like removing some punctuations. Okay, removing some punctuations. So if you take some comments in Twitter or Facebook or anywhere, definitely you will be use some smileys. Okay, smileys or some other symbols. Okay, or some other notations, right? So if you need to remove those data in your text data, if you need to remove those things means you need to use the library package. In Python, we'll be have a separate one, RE. Okay, so using that package, you can remove some unwanted symbols. Okay, so that is the use of this one. And we have fourth one, generally it's called as a stemming. Okay, stemming is nothing but like cutting off last words. Okay, for example, if you have a word like giving, you can convert your words into an give. Okay, when you are applying the stemming. Okay, so like this, whenever you are having some words, you can, it will be cut the words at the like ing or es or yes, like that it will be give the output result. Okay, so the advanced technique of stemming is like we will be have. Okay, so this is a old, like old one. Okay, old method. Stemming is a old method, but we will be have some advanced technique. Okay, so I will tell you those things and all, and some few important steps whenever you need to, you are going to pre-process your text data. Some few steps will be like these things under. Okay, tokenizing stop words and removing punctuation and stemming, those things and all. Okay, so we'll see one by one what is how we can, how the tokenizing is working, how the stop word is working, and how the removing punctuations are working and stemming are working. Then we will move on to the next part. Okay, so one of the most advanced technique in stemming is lemmatization. Okay, okay, so it will be try to give the neutralized word. Okay, for example, if you take a word like going, go, goes. Okay, so will past and present will be changing, right? For example, if you take a word go, it may be going and goes, like that it will be there. So when you are giving, when you give these words to the stemming, definitely it will be not give exact output result. So that's why we are using limitation, but stemming is the most fastest one compared to limitation. Okay, but limitation will be give the accurate neutralized word. Okay, so this is the some basic pre-processing steps in text pre-processing. So now I am going to use the package NLTK, and I am going to show you these basics things and all. Okay. So first I am going to create a new cell. Here I am creating an import NLTK. Import NLTK package. So after importing the NLTK package, I need some data. Okay. I need some paragraph to process with NLP. Okay. So that's why I'm opening the Google and sample paragraph text English I'm going to give. And here I'm having some sample paragraphs. I'm going to copy some paragraph here. Okay. So if you are working with this, you just create a new variable name, any variable name, your wish, and then paste your inputs. Okay. So here I am just paste it as a one sentence. Then I'm going to run this. Okay. Now, if you check the type of your yes, will be a string only. Okay, string type. Then, if you check length of the string, 400. Okay, so 400 is the length of the string. So now I am having one data. Okay, this is my text data. I am taking just a sample data. So to do the process like tokenizing, stop words, removing, and stemming and all. Okay, so after you are, if you are after this, you have to do first. I will tell you whatever text processing. Okay, so whatever you need to do using your text processing, the first step you have to do is tokenizing only. Okay, after tokenizing only you have to move on to the stop words or removing any method. Okay, but this is mandatory first step. So here I am going to apply for my string. I'm going to apply the tokenizing. So for that purpose I'm going to use from NLTK tokenizing. I need to import the package name tokenizing. This is the one module. Okay, in this module I am importing the word tokenizing. Okay, word tokenizing. So suppose if you want to if you have a paragraph, okay, in Python you know how to save the paragraph, right? For example, I'm creating here one new variable paragraph is equal to with 3. So if you save in this format, paragraph type of format, you have to apply the method that is from NLTK dot tokenizing import send tokenizing. Okay, why? Because you are converting your paragraph into an sentence. So at the time you have to use this sentence tokenizing, but here I am having just a string. I saved as a string type only. So here I am using word tokenizing. Okay, so there is a difference between sentence and word tokenizing. So now I am importing the package. After importing the package, I'm going to create a new cell, and here I'm going to apply the tokenizing for my variable yes. Okay. Here I am creating a new variable. In this, I am going to save my uh, like using word tokenizing. I am converting my data, string data into a tokenized format. Okay, then after that I am saved in yes underscore token. So I am going to print the yes underscore token. So if I execute this line, I am getting an error. Yes. So lookup error. It's just a package error only. Okay, now your code is not a uh, problem, but you need to import some package. So what is the package? So if whenever you are getting any lookup error, okay, so just scroll down, and here they mentioned previously how to resolve this lookup error. So you have to download the resource punkt in the NLTK. So what is punkt is? It's one type of package. It's used for word tokenizing, but the respected package will be not available in our uh, Google Colab. So you have to download the package. So where it's available, they automatically they mentioned where it's available. So we already imported the NLTK. Here you can see we already imported the NLTK. Now we just want to copy this line nltk.download punkt. So whenever you are getting a lookup error, you just scroll down, you will be have a message what you have to do. Okay, so it's not a big issue, it's not a big deal. So here you can apply here also, but for me it's habituator, so that's why here. Okay, so here you can see downloading the package, unzipping the back package, and then true. So when I get the message true, now the package is available. If you are getting fast, you need to check how it's working. Okay, so you need to run the cell. Here you can see now I am not getting any error, but my words, each and every words in sentence are tokenized. Okay, so see here, even though comma will be take it as a one word. Okay, so each and every white space available in our word tokenizing is converted into a word like this. So this is generally called as a word tokenizing. Okay, so when you check the type of this word tokenizing, you just see the type. List type. Okay, whenever you are converting your words into an using data, using the variable as, whenever you are converting the word tokenizing, this data will be converted as a list type only. Okay, you can save it in this new variable name. This is the list type. Okay, so now I converted my data. So this is generally called as a word tokenizing. Okay, you can do the same thing for even sentence tokenizing also, but you can check it out after this webinar. Okay, now I am going to like check the length. Previously I'm getting nearly 400, right? So if I check the length of my current tokenized data, 82. Okay, total length will be 82. Then now, okay, so this is what tokenizing. So here you can see my data are available. Using this data we can do like, even though we can do what are the repeated words, you can check. Okay, what are the frequently repeated words in this sentence. If you need means, that also you can check by applying one of the library package. It's available in the module probability. Okay, so if you import the probability module, the package will be available from NLTK only. NLTK dot probability. In probability module, you have a package name. It's called as a frequency distribution. Okay, F capital, frequency distribution. Generally, it will be count the number of repeated words. Okay, using that number of repeated words, automatically it will be give the output result. Okay, so here I am saving my frequency distributed words in yeah, I think we need to import this package. Okay, after importing I will save it in another one variable. Okay, so frequency dist, then I'm running. So now the package will be available in FD. Okay, so now I am going to iterate my list into one for loop. Why I am iterating means I need to check how many number of repeated words in this, right? So I'm going to iterate the words into one for loop. So I'm creating the for, then I'm going to create a word. This is a iterator for my for loop, and then sequence I need. Sequence is nothing but my s underscore token. Okay, so I'm going to open my for loop. Then after that, using FD, okay, using FD, I'm going to check the frequency words. So I'm calling FD, that is frequency distribution. Here FD I calling, and then I'm passing my each and every iterator in this word. Okay, after I'm passing the word, I'm going to convert my all the data into the lower case. Okay, I'm converting all my word into a lower case. Then I'm going to apply the data to the FD. Then FD will be checked whether it's repeated or not. Then automatically it will be saved. If it is a repeated means, automatically it will be count the word. If it is not repeated means, it will be not count, plus equal to 1. Okay, so this is a simple for loop. Now I am going to print the FD. Okay, so here you can see totally in our sentence the comma repeated for 2 times and dot repeated for 2 times and question mark repeated for 6 times, yeah, repeated for 1 time. So like that it's having shuffling. In shuffling order we are having. Okay, in shuffling order we are having this form. Suppose if you need to find the top 5 or top 6 you need. Okay, suppose if you need most common repeated words in your input data means you can use easily by applying FD dot most common, and then for example first 5 most common repeated data in my input data. Okay, so here I am going to save as a most is equal to like this. Then I am going to print the most. Here you can see totally this is repeated for totally 6 times and 2 repeated for 5 times, your repeated for 4 times, you repeated for 3 times, and is 3 times. Okay, so even though if you are increasing the 5 into and 10, you will be get an output like this. Okay, so top 10 repeated values in your NLP. Okay, so that is the uses of this frequency distribution. Okay, so even though you are having some other packages also, okay, like n-grams or bigrams or trigrams, so that also it's a type of tokenizing only. Okay, so generally what is try? Like try is nothing but three time, right? So if you are applying this trigram, okay, for your sentence, it will be tokenized your words three time. Okay, so that is the use of trigram. Otherwise I will show you. Wait, just wait. From NLTK, we are going to build an util and then import n-grams. Okay, n-grams are, we will check for bi-grams. Bi means 2. Okay, right? I think if the package is not available, we will be get a lookup error only. We'll check it. I'm going to use okay. So now I imported a bigram, right? So after applying this bigram, I'm going to create a s underscore by one variable name. Here I'm going to create on list. See guys, this is the inbuilt function. Whenever you need to, whenever you are going to create a new list, you can use either like this syntax. This is the use. You can create a use using this also. Suppose if you need to create a list in using inbuilt function also, you can create by applying this inbuilt function. Okay. So here I'm applying NLTK dot, okay, bigram, yeah, bigrams. Okay. Then I need to call my s underscore token. Okay. Then if I print the s underscore bigram, we are getting here output like this. So this is another one type of tokenizing, two words tokenizing. Okay, so that is the use of bigrams. Suppose if you need this one for 3 times repeated words, means you can use trigrams. Okay, so here it's not displaying, but we have trigrams, and then even though we are having n-grams also. So trigrams in basically name itself, we are having a suggestion 3 times. If you take a n-grams, n, here n is nothing but how many times you have to give as a repeated words, 5 times or 6 times or 7 times like that. So that is the use of n-grams. Okay, so just to check it out after if you are free. That is the use of tokenizing. Okay, so till now we seen only a tokenizing, right? So this is the way you can do your process during whenever you are going to pre-process your text data. Okay, this is the first step in text classification. After this, you need to do some other process also like stop words, removing and stemming. This and all we can do easily. So just I will show you the demo how we can do those process. The next process, like till now we done with tokenizing only. The next thing I'm going to show you another one steps in that. The thing is like, okay, just wait. Stemming, okay. From, yeah, we are going to see stemming, how we can do stemming. So just I'm taking a random words and I will show you nltk dot stem. Nltk dot stem. So here stem import port stemming. Okay, so here I'm going to use port stemming and nltk dot stem import port stemming, and pst is equal to, that is I'm saving the port stemming package in one variable. Okay, so sorry, here port stemmer, yeah, I have to import, so that's why I'm not getting a suggestion. After importing, you just create a new cell and check the suggestion port stem. Okay, after this whatever input you are giving, it will be do the process and then it will be give the output. Okay, so for example I am calling here pst. As I said before, stemming. Okay, so here I'm going to give the word. For example, we can take it as a eating. So eating, you can normalize into an eat. Okay, suppose if it is a running, you can get it as a like this. Okay, so this is the way you can convert your data into a like this neutralized way, normalized your data. Okay, so that is the use of stemming. So after stemming, I will show you the which one. Okay, stop words. Okay, after this, I'm going to show you how we can do the stop words. Stop words. Okay, so stop words is basically used for like uh, removing some neutral unwanted words in your paragraph, like is, there, are, have, those things and all we don't need, right? So you can use these stop words. For example, you can import from sklearn. Sorry, this is that one, right? So from NLTK, from NLTK dot corpus import stop words. So here I'm importing the stop words. So using these stop words, you can get the output results also. Suppose, for example, here, if I need to see the what are the stop words available in our data, if you need to see means the stop words will be available for like different language. Okay, so NLTK is not only used for English. Okay, we have it's available for different type of languages. Okay, so in that I'm going to use only the what we know, English language only we know. So we are going to check the stop words available for English. Okay. So I'm using here, yes, not giving suggestion. Maybe not have the packages will be not available, suppose. Okay. So I'm printing English. Yes. So as I said before, if you are getting a lookup error, you can just scroll it, run it, then back to the last cell and run it. Okay, so see here, these are the stop words available in our English words. I, me, my, myself, we, ours, ourselves, you are, you have, you are. Okay, so these are the stop words are available. Totally, we are having like n number of stop words are available. So if you need to check the total length of the stop words, you can check by applying the length function, inbuilt function, len 179. Okay, so totally 179 stop words are available. So when you are, suppose if you are applying the stop words for your input words, automatically it will be removed when it's matched. Okay, suppose if you have a word, this is not automatic in your sentence, automatically it will be removed from the sentence. So that is the use of stop word. So here you don't need to confuse, because this stop word is different and RE. Okay, I already told you that removing the punctuations and symbols. So that also different. Okay, so this is different. This removing punctuation. This one is different and this one is different. Okay, so remove stop words is just you will be have 179 words. If it is matched, it will be removed. But here here it will be used for removing the punctuation symbols, those things and all. Okay, so I will show you how it's working. Okay, now for example, suppose if I use, if I take our, input. Okay, I'm importing an RE, and then I'm importing the punctuation. Here I am saving punctuation. I'm compiling first of all what are the things I don't need. Using RE function, I'm going to compile what are the uh, symbols. Okay, what are the symbols I don't need in my input data. So in our input data we are having the symbols like comma and question mark, those symbols and all we are having, but I'm going to remove those symbols, okay, by applying this RE. So after compiling, you have to R to read, and then open and close. Here within this you can give your like what are the symbols you don't need, you can give. Automatically it will be removed from your input data. Okay, so now I am just to compile some few random symbols. So the compiled function will be available in punctuation. Then I am going to create a new cell, and I'm going to apply the word s underscore token. I'm calling my underscore token data. Okay, so here I'm having an, I'm calling my s underscore token, sorry, this one, tokenized word, and I'm going to create a new variable word is equal to punctuation. So here what is this punctuation represent? The compile function we you done by using RE, right? So here I'm calling the punctuation, and I'm going to sub my punctuation with my input words. So what are the inputs words? This one, right? So using this input word, that is during after iterating the each and every word in my s underscore token variable, I will pass the data to my punctuation dot sub function, and here words. Okay, then after this I'm going to create a if, and I'm going to check the length of my word. That is, whenever if the s underscore token iteration was finished, we have to close the for loop, right? So here, when if length of the word, okay, so length of the word is greater than 0, okay, you can post. Otherwise, you have to save it in one list, right? I will create a new list. Post punctuation. I'm going to create a empty list, and I'm going to save this data in empty list. Dot append. Append my word. Okay, so this is a simple for loop. If I execute this line, and then if I print the this list, my empty list will be converted into a like this. Okay, so here you will be has some dot is there, right? Dot we given or not? We not given the dot here. Okay, so that's why it's not removed, but question marks and all is there previously, but I'm not having those question marks. So that is the use of this removing the punctuation. So like this you can work on with your input data. Okay, if you are data having in a text type of data. Okay, so till now what we are seeing, it's a one part of the text pre-processing, but after this, till now we are having our text into an like this only, right? Till now our text in the form of text data only. Till now it's not in a reader form, that is machine understandable form. So when you need to convert this text data into the machine understandable form means we are having some basic packages, okay, to convert your text into an numerical form, that is machine understandable form or algorithm understandable form. So the basic packages, if want to do means like they will call as a BOW, bag of words, and we are having uh, back of force is one of the technique, it's one of the oldest technique, okay, so you can collect all the ranking of your word and then it will be find by binary classification, that is 0 or 1 like that. It's a one of the technique converting your text into an machine readable. Then we are having another one function like TF IDF, term frequency inverse document frequency. So how it's working? Actually, we have a separate formula for term frequency and inverse document frequency. Like term frequency is nothing but repetition of words in a sentence divided by number of words in a sentence. So that is the use. That is the term frequency. And then inverse document frequency is log of total number of sentence divided by number of sentence in a word, okay. So this is the formula. We need to, after we are getting some answer between these two term frequency formula and IFDF frequency formula, we need to multiply those data. So that is the use of term frequency and inverse document frequency. And we are having some other techniques also like word embedding, and word to vector, okay. So even though if you're taking a deep learning deep learning side, we are having a packages like pytorch pytorch packages and Keras and then TensorFlow. So these are the packages will be helpful to convert your data into a machine understandable form. So from starting onwards, I am telling you one thing. If it is a text data means we need to convert our text data into the machine understandable like that. How we need to convert? So that is definitely will be have one question, how it's performing, how our output will be there. Those things you will be have some definitely. So I will explain it in Jupyter notebook. Okay, so here I already have a uh, that is convert to sorry, bag of force technique. Okay, so count factorizer. Before that, I will tell you some basic example and how it's working. For example, you will be have a word sentence one and sentence two. Okay, so sentence one we are having words like Raja is just a simple example. Okay, goodbye. And in sentence two we are having Raju is bad boy. So here there is a uh, almost the both the words are similarities same only, okay. So similarity is same only but the wording is different, good and bad, Raja and Raju, okay. So when I apply this to my word to back of words function, that is count factorizer. Count factorizer is the back of word generally called as a from SQL feature extraction dot text count factorizer. So when I apply this technique, how it's performing the result, we'll see. Okay. So first of all, I will take all the rank of words available in my both sentence one and sentence two. Even though n number of sentence available, first it will be check the rank. It will be rank the each and every words. Okay. How it's ranking means by using like this sentence one, sentence two. Okay. So here I will take Raja is a good boy. Okay, then Raju is not repeated. Raju then is repeated, yeah, repeated, bad repeated, and by also not repeated. So this is the ranking of my sentence 1 and sentence 2, ranking words of my sentence 1 and sentence 2. So now if I apply the count vectorizer, that is back of words technique to my sentence, I will be get an output result like this. Raja will be repeated in sentence 1, yes. So here it will be a 1. Okay, then is repeated for repeated in sentence 1, yes, 1. Then yeah, yes. Then good, yes. Bye, yes. Raju 0, bad 0. Okay, so like this it will be take the each and every words. Then again Raja is repeated in sentence 2, no. Then is, yes. Then yeah, yes. Good, no. Then bye, yes. Then Raju, yes. Bad, yes. Okay. So here you can see I'm getting the output result of my sentence 1 and sentence 2. So by using this data, algorithm will understand. But here some problem is there. Okay. Here you can see it's having some pause. It will be have a repeated words like 23 comma 23 24 comma 25 like that. Some continuous words will be available. So generally it's called as a sequence word. Okay. So it may be sequence is nothing but like continuous values. Okay, like 4.2, sorry, 42, 43, 44, 42, like that. Some continuous values will be there. So whenever you are having like this continuous type of data, sequence type of data, you have to, for that separately, for that purpose will be have a separately some algorithms are available in machine learning and deep learning. Okay, so in deep learning generally we are having a recurrent neural network algorithm, so especially it's used for sequence type of data. So that's why in today's session also we are going to see the how the sequence type of data you will be training and predicting an output result by using recurrent neural network algorithm. Okay, so this is the simple method and simple example how the backup watch is working. If you take a TF-IDF, it's totally different. Okay, it's totally, we will be get a decimal values like 0.26 or 0.23 like that. Decimal kind of values will be available after applying this TF-IDF. TF-IDF also available in sklearn only. Okay, so here you can see from sklearn feature extraction, text, import, term frequency, TF-IDF vectorizer. Okay, then go to embedding. Okay, word to embedding, word to vector. These are the some other advanced. Each and every technique will be have some drawback. So that's why we are trying to using this one. Okay, so we'll, for example, in back of words will be have a drawback like here we are getting a representing an output 0 or 1. Okay, so for good also we are getting a 1, for bad also we are getting a 1. So some semantics are missing, that is some correlations are missing in back of us. So that will be overcome by TF-IDF. In TF-IDF also we are having some disadvantage, so that will be overcome in word to vector, word to embedding, and then word to vector. Then now we are having some advanced technique. Okay, so the technique is like encoding and decoding or BERT. Okay, so BERT is nothing but we can convert our even sentence also into an vector. Okay, so generally BRT. Okay, so this is the one of the advanced technique, text pre-processing. So you can convert your even sentence to vector. Okay, so that is the uses of this packages. Okay, so now I will show you how the word to vector, sorry, back of words are working in real time, back of words and TF-IDF. Okay, so I am using here Jupyter notebook. So here I imported the package and list of text document. Here I am applying one, say here I'm creating a new text variable, and here I'm saving my one data. The quick brown fox jumped over the lazy dog. So this is my input text data, and here I'm creating the transform. What we are creating, I'm saving count vectorizer in one variable. Okay, then I'm going to fit my text. So here I'm having these strings will be saved in the text. Then I'm going to give the text. Then it will be vectorize the your input data. Then vectorized data will be converted into an vector. Okay, so here I'm using vectorizer dot transform that text. So here I'm having a vector. So now I'm going to check the shape of my vector data. So what is the shape of my vector data? 1 comma 8. So 0 1 2 3 4 5 6 7 8. So we are having single row 8 column, right? Exactly like this. So one row and 8. 1 comma 8, yeah, it's of course it's a 1 comma 8 only. Then vector, I'm displaying my output of my input data. So after I am converting my data, I'm getting an output result like this: 0 comma 1, 0 comma 1 2 1 2, like this. Okay, so that is the use of vector. So for example, if I here it's not getting an exact, it's not clearly understanding, so I am converting my vector into an array type. So here I am displaying. So this is my output result for this input data. Okay. So like this, you can apply for using count vectorizer, that is back of words. And if I use text to the puppy, okay, then I'm vectorized into the, and I'm saved in vector. So what is the this sentence output is 0 comma 0 comma 0 comma 0, like that, and 1. Okay, so 1 is nothing but my input data, this one. So that is the way you can convert your data into an vector form. Here we are having a TF-ADF, term frequency inverse document frequency. So here also I'm giving a same input, but now this time it's changing to 3 input. Okay, so now I'm vectorizing the output, same, fitting the output, then vectorize into the vocabulary and IDF, then shape and to array. Okay, so here you can see we have an option, we can see the vectorized vocabulary. Okay, so vocabulary, here you can see there have a 7 index value, quick have a 6 index value, brown 0, fox 2, jumped 3, like that we are having some index value. So if you are giving newly one input text data to the vectorizer form, there is the fixed one. Okay, so whenever we are having a there in your input data, it's always give the index value 7. So that is the use of vector TF-IDF. Okay, so here I'm getting an output result of my TF. So already I told you our output will be in the form of a TF-IDF in decimal type only. Okay, so here we are getting as a decimal type. Okay, so this is the way you can convert your text into an, after done this all basic steps. Okay, this is the that is the way you can convert your data into an numerical form. Okay, so I hope now everybody will be get into the idea of how we can convert, how we can pre-process your text data, and how you can get your data output result. Okay, so after I'm getting this output data, I'm going to train my algorithm and predict the input data. So this is the simple thing, guys. Okay, so I already told you in first class and second class itself, the way the training of algorithm and predicting an accuracy result and all very easy. But before that, we are doing some pre-processing step and feature extraction step and some other steps and all. It's somewhat difficult. Okay, it's a complex one. That is data science. Okay, so now I'm going to show you one real-time example. Okay, the example is this one only, using recurrent neural network algorithm. Okay, so here I'm using the data set of IMDb. Okay, I think you guys will be know about this IMDb. Okay, IMDb is nothing but movie review website. So we are going to use that website reviews, and we are going to check how it's performing the output result. Okay, so for example, 1000 IMDb, right? IMDb movies review dataset. Okay, sentimental analysis. Here I am moving for the first Kaggle website. Any description available here? We can observe both input. IMDb dataset having a 15K movies review of natural language processing and text analysis. This is the dataset of binary sentiment classification using substantially more data than the previous benchmarks. Okay, so predict the number of positive and negative reviews. Okay, so we have to train the some data, and we have to predict what are the positive reviews or what are the negative reviews. So this is the data set. Here we are having an data set. Okay, so using this data set only, we are going to analyze the our recurrent neural network algorithm. Okay, so RNN, here I'm importing this data set will be imported by using Keras data set and import IMDb. After importing this, I'm going to take a vocabulary size. What is this vocabulary, guys? Vocabulary size is nothing but here I'm taking 5,000. So here, what is the vocabulary size? Like, uh, where is my simple example? See, 1, 2, 3, 4, 5, 6, 7. 7 is my vocabulary size. So like this, here I am taking a vocabulary size as a 5,000. Okay, so up to 5,000 words in my ranking data, it will be take. So that is a thing here I am giving. Okay, 5,000 vocabulary size. Then next one, so within this 5,000 vocabulary size, it may be an minimum, or it may be an above 5,000, or it may be an equal 5,000. Okay, totally I'm taking a vocabulary size 5,000. Now I'm going to import my data. Okay, using IMDb, I'm loading the data. Okay, using Keras package, I'm loading the data. Then I'm going to save my data in one variable. Okay, so this is already we seen in machine learning also. X train, Y train, X test, and Y test. So we are dividing our 25,000 data uh, training samples and 25,000 data testing samples into two part, that is X train, Y train, and X test and Y test. Okay, so here also I'm mentioning the size of my vocabulary. So here I already mentioned, and just I'm giving a number of words, 500. Okay, then next thing I am going to see the output of train data 7th review. That is, in train data we are having totally 25,000 train data. In the 25,000 train data, I'm going to check 7th review. Okay, if I check the 7th review, I'm getting output like this. I'm getting output like this. So now you will be comes to know what is this outputs and all. Okay, so previously I showed you text processing, text pre-processing. Okay, text pre-processing previously I showed you, right? Like this same thing only here also we done. So we previously we are having some review data. Those review I am converting, and I saved in the Xtrain data. Suppose if you need to see also, we can see. For that we have a package. I will tell you. Okay, how we can see them. Then Y train, I'm getting what is the 7 output result here, 0. Okay, So now I'm going to convert my this index value into an word. For that purpose, I'm using get word index function. Okay, I'm using get word index function. Using that function, I'm going to convert my these numbers into an real reviews text data. Okay, so that is the use of this one. So get word index, I'm saved in word to id, and then here I'm calling each and every items. Okay, so here also you can see my each and every items has keys and values, right? So like same thing only available here also. So I'm calling that one using for loop. Then I'm saved in id to word. Then I am checking the output result. Okay, when I run this cell, here you can see this is my review of my this data. So here I'm getting a numerical data. I converted my numerical data into a text data, then I displayed here. Okay, so this is my data. Okay, so this is the way you can convert your data. Now I'm going to check the maximum value and minimum value of my train data and test data. So maximum review length in my train data is 2697. Okay, and minimum review length in my x test and y test is 14. Okay, so maximum and minimum is this one only. Now I'm going to wait a minute, I forgot to execute the previous cell. So this is my maximum dividend. So now why I am checking like this means I'm going to save all my data into an same input and output. Okay, that is uh, like this. Yeah, here I already mentioned. So this is some random text. Okay, this is also random text. Okay, some minimum data will be like this, some maximum data will be like this. For example, I am telling, so using paired sequence method, I'm going to fill some null values to compromising this, that is equally I am saving all my data equal length. I'm saving the all my data into equal length. Okay, so that is the use of this one. And so for that purpose only we are using a paired sequence. So using Keras, I'm importing the pre-processing and sequence and paired sequence. So I'm both X-train and X-test. I'm going to take it as a only maximum word 500. Okay, so here 269 is my maximum review length, 14 is my minimum review length, but I am taking here only 500. Okay, so then I am going to use sequential model and embedding LSTM dense and dropout. So here embedding is nothing but we are using here text type of data, then LSTM long short term memory. Okay, so whenever you are training the LSTM algorithm, it will be trained by applying the trained by previous input and current input, previous weight and current weight. Okay, so that is the use of LSTM. And dense, we already know what is the use of dense. And dropout. Dropout here is nothing but um, to minimize, to overcome the that is whenever you are training the any deep learning algorithm, it leads to overfitting. Okay, so to reduce the overfitting, we are going to use dropout function. So dropout function is nothing but it's just uh, drop some unwanted neurons weight data. Okay, so that is the use of dropout. So here I am building my using sequential embedding LSTM and dense. Then here I am seeing the summary result of my model. Then binary cross entropy, yes, we seen yesterday. This also, Adam also we seen, accuracy also we seen. Then batch size, port size, this also we seen on yesterday. So just we are training our model, X train, Y train, X validate. And after training the model, we are going to evaluate our result. Okay, so we are getting a 86% accuracy result. It's a nice accuracy result only. Okay, so like this you have to do with your recurrent neural network algorithm. Okay, so here what we seen about word, how to classify the words and what are the basic concepts in our uh, input. That if you are having an input, what are the basic concept you have to use, and then how to convert your text into an converting into the text into a machine understandable, that is vector form, and then how you can build your RNN by using Keras and TensorFlow. Okay, so up to this, I think most of the persons will be understood. So if you have any other queries, you may ask now.
Thank you, sir, for your stimulating and fruitful webinar section. Now let's move on to the question and answer session. Sir, how to tokenize a sentence using the NLTK package?
So how to tokenize the sentence here? Yes, where it is. This is what I think I done. This is word tokenizing. Okay, so sentence tokenizing is nothing but here I saved my input as a like this means like in single line. Okay, so if you have a paragraph, you can save the sentence into a paragraph. Okay, paragraph paragraph and then after saving it to the paragraph, and you can apply this sentence tokenizing. Same thing, instead of the here word tokenizing, you need to use sentence tokenizing, and then here you need to give your variable name paragraph. Okay, then you can convert your paragraph into a sentence tokenizing.
Okay, sir. Sir, which is the most powerful parsing method in Keras?
Powerful
Parsing method.
parsing method. Okay, so parsing method, like I didn't told exactly this is the parsing methods. It's most important in Keras, but based on the data set, it may be changed. So suppose, for example, if it is a sequence type of data, means we need to use most important techniques like here you can see we need to use this padding sequence, or if it is an continuous, if it is a time series analysis, means we need to use some other smoothing method. Okay, using smoothing we can convert our data into an parsing like that and all, but based on the data wise it will be changed.
Okay, sir. Sir, which is better, LSTM or RNN?
Yeah, that is a nice question. Actually, here RNN, the difference between this RNN and LSTM is nothing but this is actually RNN, recurrent neural network. The way of working is different. For example, I can use Paint. So what is the workflow of recurrent neural network algorithm means? For example, if I give a input, okay, if I give a input X to my neuron, okay, so neuron will be compute the input data, then it will be give one output result, that is y hat. Okay, previously in yesterday's class I told you prediction result will be a y hat and original result will be a y, right? So here I am getting a y hat, right? So during this process, definitely my neuron weight will be updated. Okay, so this updated neurons will be automatically transferred to the another next layer of the recurrent neural network algorithm. Okay, so this is the process of RNN. RNN will be learned from the, like, for example, if you take a stock market prediction, in stock market prediction, we will be have a day by day data, right? So if you are missing 1 month data and if you are training the output, means you definitely will be not get a exact result. So we need a day wise each and every data. Okay, so if you have that like that day by day data sequence type of data means better you can use recurrent neural network algorithm. Okay, so in recurrent neural network algorithm only we are having on package, that package is called as a LSTM. Okay, so we have LSTM and we have bi LSTM also, bilinear LSTM and LSTM. So what is the use of LSTM means it will be have a separate memory. Okay, separate memory of each and every data. Okay, for example, suppose you are training some stock market prediction of data, so some changes will be occur. So, for example, stock market prediction means based on the trend it will be changed, or based on the season wise it will be changed. Okay, suppose it will be changed based on the season wise means if some changes will be there means it LSM will be takes those important data and save it as a separately. Okay, whenever it will be required at the time it will be take. Okay, so I am telling as a theoretically, but LSTM will be have some memory based. Okay, so in RNN only we are using an LSTM. So here based on the data, same answer only based on the data we need to use by LSTM or LSTM or any other neurons also our wish only. But recurrent neural network working is this one, but LSTM in that within that part only.
Okay, sir. Thank you for your explanation, sir. Now it's time to express our gratitude. On behalf of the Department of Electronic and Communication Engineering, St. Joseph Institute of Technology, St. Joseph Groups of Institution, I thank our guest lecturer, Mr. S. Kamlesh, sir, for this encouraging speech on neural network in Keras. Thank you, sir, for taking out time from your busy schedule and joining us to share your knowledge. I would like to extend my gratitude to our chairman, Dr. B. Babu Manoharan, sir, and our managing director, Mrs. B. Jessie Priya, ma'am, and director, Mr. B. Sashi Shekhar, sir, and our principal, Dr. P. Ravichandran, sir, for giving this great opportunity to conduct this webinar. And special thanks to our department heads, Dr. C. Nyana Kausalya, ma'am, Professor and Head of Staff and Student Affairs, and Dr. G. Rohini, ma'am, Professor and Head of Lab Affairs, for their support. I thank each one of our staff coordinates and the organizing team for arranging this webinar successfully. And finally, my sincere thanks to all the participants for your active participation and support. Once again, a big thanks to Mr. S. Kamlesh sir for your presence. Thank you all.
Yeah, thank you all. Tomorrow is one of the most important days. So those who are waiting, like we can train the image and we can predict an output result by using convolution neural network algorithm, like object detection. Okay, so please attend the tomorrow's webinar also. Don't neglect as it's a last day. Tomorrow webinar also somewhat important one and important for like current technology. Okay, so please ensure that and attend. Thank you.